All right, so I'm on 52 weeks of Rust here live. And last time I covered some ownership topics, and I'm going to continue to do that. So I'm going to start off with sharing my screen here and get right into it and pull this up. Just give me a second here. So let's share my screen. Here we go. Make sure I've got it as wide as I can here. Let's see here. Looks pretty good. There we go. Okay, so I've got 52 weeks of Rust. I think last time I had some issues with ownership, right? That's really where I was starting on, and so I'm going to go into my code space, which is the recent one that I was working on, and just dive right into it. And I think I'm sharing the wrong thing though. I'm doing like kind of a meta share. So let's see here. Here we go. That's better. Although, that is weird how it's the share. There we go. That's better. Okay, so I've got the topic of ownership. I'm going to open up a new terminal here, and if I remember correctly, I can go to the Rust documentation and dive right into this. And I was at the concept of ownership, and I'd gone through a little bit of this stuff. So, I mean, I guess the idea is that basically the memory cleans itself up. I mean, that's really the main concept here. And what I can do next here is take a look at referencing and borrowing. So let's go ahead and play around with it and see if I can understand what's happening. So if I go to here and I just make another project, let's go ahead and look at the history. Let's go to cargo, new ownership here. We'll call this EP6. EP6. Let's go into there. Ownership. There you go. And if I look inside of that, I can close all this stuff up, get into this, and just paste that other snippet here. So what do we got? So we have a main function. We're letting a string be defined, and then we calculate the length of the string here, and then we have another function that is able to accept a string and then give the length of that string. And so the calculate length here is called in the main function. And so let's, I guess, go ahead and run this. So we'll say cargo run, and the length of the string is 5. Okay, so what did that tell us though? The return value is gone, right? So it's basically able to automatically clean things up here. That's the main idea. You can also make mutable references. Okay, dangling references. We see some stuff. Oh, that's good enough. I feel pretty good with ownership. Let's keep moving to structs here next. So a struct is a custom data type that lets you package together and name multiple items as a group. And so let's try it out. Let's try out structs here. So they're similar to tuples. So here's a struct here that we can copy. There's a user, and it's got several attributes inside: active, username, email, sign-in count, and then we've got the main function that makes an instance of that user. So let's copy this first, and let's throw it in there. And what we do want to do is have a main function here. So let's go ahead and copy this. I guess we could do that. Struct user. Oh, show that. We need to put this. There we go. So we have the user struct. In the main function, we make an instance of it, and we basically fill out each of these attributes. So the email is a string, the username is also a string, and then active is a Boolean or a bool, and then sign in count is a U64. And if we run that, cargo run, it works, but it just says it was never run. And changing the value, notice the entire instance must be mutable. Rust doesn't allow us to mark only certain fields as mutable. So you can mutate this here. So what did we do before? So we had a immutable, but then if we do a mutable, we make user, oh, I see. And then we assign it again. So we create it and then we assign it again. Okay, that's interesting. Let's try that out. So let's take this here and let's run it. User must be defined only once in this module. Oh, well, I must have accidentally put that in. There we go. So that's nice that it caught that for me. There we go. And we understood how that works. Using a field in its shorthand, creating instances from other instances with struct update. Okay, that looks pretty clear here. You can use a tuple struct without named field. Unit-like structs with any field. So basically, they're kind of a fancy tuple. That's good to know. Okay, now let's do something with it. So here's an example program using structs. We have an area function, and we make an instance of that right here. And let's make a binary project. That's one way to do it. So this would be the classic way to do it. I'm assuming they're going to use a struct way. Yeah, okay. I was going to say, like, I don't see the structs here. So let's go ahead and pull this in. Let's do cargo run. There we go. Area is 1500. Okay, so now let's refactor it with tuples. Does it make it easier? Let's see here. Let rect1 equals 3050. Area rect, and that gets, I see. So we then pass that in here. We specify the width and height. And let's look at the difference here would be, oh, I see. So these are just individual variables, but in this scenario, we give it a tuple. So let's copy that. It looks pretty straightforward. We run this cargo run. There we go. So it's kind of a similar thing. So this, in one way, this program is better. The tuples give more structure. We're passing one, but they don't name their, I would say that's the downside, is that these are not named elements. Like, are they width or height or what are they? So I see. So here we go. Here's a refactor with structs that you have there we go. This looks a little clearer, right? So we have a struct, which is rectangle. It's got a width, it's got a height. We make a main function, which is right here, and we make a instance of that struct, and we populate it with values. And then we call the area function, and we pass in that struct into the area. So yeah, that looks pretty clean. I like that. It looks actually pretty intuitive. Even if you're not a Rust expert, visually you can kind of look at this and go, okay, yeah, this makes sense. And we can go ahead and say cargo run. So yeah, it's interesting. I mean, when I'm looking at Rust code like this, it's fascinating how it looks like a combination of Python and Swift, but even easier than Swift. And just kind of taking a look at this. And okay, what else can we do? We have added useful functionality with derived traits here. So in this case, we're debugging our program. So we see, again, we have the struct with named values here, width and height. These are U32 types. And then an instance is made of the rectangle struct, and then it's printed out. The rectangle is, okay. When we compile it, we get this. Rectangle doesn't implement. The macro can do many kinds, but it can't do println. So how do they do this? So they say struct. The rest does include functionality to print out debugging information, but we have to explicitly opt in. Wow. Okay, this is kind of cool. So now I'm learning something new here. So if I go here and we say derive debug, you say struct rectangle, make a width and a height that are U32, make a main function, let a rectangle be instantiated, put in width, put in height, and then go ahead and put in this question mark. And let's see what the question mark does. So by adding attribute to derive the debug traits using debug formatting. So this must be the debug formatting. And we say rect is, oh, so I guess it can print an object. That's, wow, that's actually pretty slick. I like this. So if we go through here and we say cargo run, there we go. So we see, I guess this can print out whatever's inside of an object, which is, again, pretty cool. That's nice to know. And also calling debug macros prints to standard error as opposed to println, which prints to the standard out. I see. So basically, standard error is where Unix programmers will put their error messages if there's a problem, let's say running a Unix command, and standard out is typically where you would have logging information that would go out. And so here's an example where we get an assigned value in the whole struct right here. We copy this and we put it in. Derive, debug, great. So we got this thing cooking. We again go to cargo run. And if we look here, is this the debug right here? I guess is the you can put the, by calling debug macro, it prints to the standard error stream as opposed. So that is actually very interesting. So if you do this debug exclamation points, it will print out the entire state of the object. In addition to the debug trait, as number of traits to use with derive. So yeah, pretty cool. I like this. And methods are similar to functions. We declare them with fn, and they contain some code that's run when the method is called from somewhere else. Unlike functions, methods are defined within the context of a struct. Okay, so this is interesting. So let's change the area function. So this looks like a pretty cool one. Let's take a look at this, and let's see here. So we have a debug derive here. I've got a struct, which is a rectangle, and then I guess if you use implement, this then creates. I guess this is kind of a inheritance type feature. It appears to be, which is I inherit from rectangle and I add a function or a method in this case, right? And notice the self here, which means that I can access this the object's state. And then in this case, I use that to do a calculation. And then now when I call it from the main function, I just say let rect1 equals rectangle, width is equal to 30, height is equal to 50, the area of the rectangle. It's very, very clear to me. Actually, the more I look at Rust here, I actually like it better than Python classes. This to me is quite clear the way this code looks here. And I guess what I would be kind of curious about is if I put a little bit of extra information in here, like if I did, I don't know, like a print, for example. So this one returns this value. I'm kind of curious if inside of here, if I could do like a print ln, Sure. Let's try that. Calculate an area of rectangle. And then if I go cargo run, yeah, there we go. So we see like I'm able to put some other stuff in there. And what happens if I put in the print statement here? Let's see if I was gonna put something like this in there. Let's do that. Let's do, in this case, let's do self.width. Self. Let's just double check that my syntax is right. No, we don't want that. We do want this. There we go. Now if I run this, check in the area of rectangle, self.width. Yeah, pretty cool. So yeah, pretty clear to me how this works. And in C and C++, two different operators are used for calling methods. If you're calling a method, blah, 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 an object is a pointer. Rust doesn't have the equivalent. Instead, Rust has a feature called automatic referencing and dereferencing. So calling methods is one of the few places that has this behavior. So when you call a method which object does something, Rust automatically adds in the following. The first one looks much cleaner, and the automatic referencing behavior works because methods have a clear receiver, the type of self. All right, so let's make another method with more parameters. There we go. And let's throw this in. We say fn main, and in this case, we have a rectangle. Let's run this. Let's see if this works. Yeah, we need that. We need that rectangle struct here. So I think we need. Do we need this? Let's take a look. So if we go here, let's do that. Found rectangle. We can hold. Where was that kept? Rectangle. Rect1 can hold. Yeah, where's that coming from? Oh. Implementing can hold takes another rectangle instance as a parameter. So maybe we need to swap that in and put that in here. And okay. Yeah, interesting stuff here with structs. I could see I'm getting a little bit motivated to write some real Rust code here, especially because there's not much more. I guess there is. There's actually, I'm about, where am I about? A sixth of the way through. So through the lesson. So maybe a few more weeks here, and I'll be able to start building some Rust code. Maybe I'll take a break, but yeah, in general, interesting stuff here with Rust, with structs, and pretty intuitive.